We'll now take a closer look at a group mean comparison. That is when you have a categorical X and a continuous Y. Our objectives here are to identify when to use the means comparisons, apply the four-step method of hypothesis testing that you learned in the prior module to difference and mean tests, interpret results from a means comparison, and report the results from a mean comparison, and then construct the appropriate graphical display for a means comparison. So let's go back to the question, as it always goes back to the question. Before we can run an analysis, we need to define the question. For a means comparison, you'll need two variables. This is a bivariate analysis. One is categorical, that's your predictor, that's your X variable. The other variable, or your outcome Y, is continuous, meaning it's a numerical response. There are no categories in your Y. The responses are free numeric responses. So age is an example of a continuous variable. Systolic blood pressure is an example. Weight could be a continuous variable. Time it takes to walk 25 feet could be a continuous variable. So let's look a little bit closer here at our X and our Y and how we would state the question. Remember, there are multiple ways to state the questions that are associated with hypotheses, and the way that you ask the question should make sense. You wouldn't say in conversation, does sex differ by mean age? You would say, does the mean age differ by sex? That is, do men and women have different mean ages in our sample? And this really does matter. Switching your X and Y here is not advised. You would go from a means comparison to what is called a logistic regression. And we don't look at logistic in this course. A logistic regression is a continuous predictor, continuous X with a categorical outcome. We don't do that here in this class. It's a very common type of analysis. You'll get that in more advanced classes or if you take any statistics courses in graduate school. So be very clear. For a group means comparison, your X is categorical and your Y is numeric. And how do you know that you phrased your question correctly? Well, you want to compare the mean outcome by your groups. Remember, fit Y by X. Continuous outcome is Y by our categorical predictor X. So how do you do the analysis? Well, you've seen already that it is fit Y by X and jump. Put your group predictor as X. We'll look at things like gender. We'll look at things like race. We could look at drug A or drug B. Anything that's in categories. Your numeric outcome is your Y, and then press OK. Let's take a quick look at our jump output here. Remember, you get a basic bivariate graph with your categorical variable on your X-axis, female and male, and your continuous response on your Y-axis. This is data from the zip bike data, which can be found earlier in the course. The one way refers to the fact that there is one categorical variable and your continuous outcome. This is also called ANOVA, analysis of variance. A few things on this plot to pay attention to. The gray bar is the overall mean of the outcome. Remember, you can get that from analyzed distribution of age. X-axis, that's your groups, males and females here. It shows the outcome on the Y-axis, that's age here. And the points observed are the observed outcomes. Now, if multiple people have the same age, you'll only see one dot. Note that this is not the analysis. You need to use the red drop-down arrow next to the one-way analysis of age in JUMP. First step in JUMP is to ask for the quantiles and then ask for the means and standard deviations. And we can see here that there are 15 males and 15 females. The median female age is older, the male age is 27. However, the range of ages looks relatively similar, though we do have one outlier in each of the groups, with the highest age being 74 in the female riders. We have a mean age of 38.8 in the females with a standard deviation of 14.5, and a mean age in males of 31 years of age and a standard deviation of 11.5 years. Remember, we need to start by defining our question statistically. We have a null and alternative hypothesis. Our null hypothesis is that the mean age for males is the same as the mean age for females. And our alternative hypothesis is that the males and females have a different mean age. You'll want to look at the probability greater than the absolute t p-value. So over on the pooled t-test results, there are 3 p-values. Here we want to look at the two-sided test, meaning we're looking at no difference in the null hypothesis or a difference in means in the alternative hypothesis. Our p-value here is 0.1139. This is greater than our alpha value. It's a large p-value, which means we'll choose the null hypothesis or fail to reject the null hypothesis and conclude that there is no difference in mean age of zip riders between males and females. The way that you would write this up in a summary is the overall mean age of zip riders in Birmingham, Alabama, with a sample of 30, is 34.9 years with a standard deviation of 13.5 years, and there is no statistical difference in age by gender, listing the female age with standard deviation, the male age with standard deviation, and then the p-value. It is important to note here that you get the overall mean from analyzed distribution. Because we concluded there is no difference, the overall mean may be the best summary statistic, but it's also important to show the age by gender. Now you might say, well, 38.8 and 31 seem like they're far apart. But remember, you have to consider the standard deviation. And you have to consider the overall distribution of ages by gender. So while the mean age for females is observed to be higher because of our small sample size and because of the large standard deviations involved, we cannot say that the male and female zip rider mean age is statistically significantly different. How would you display these results if you wanted to use a graphical display? Sometimes a sentence is enough. Again, you can take a look at the men and women ages from the prior slide. Here's a more simplified version. If you have many variables that you're summarizing, like for your data brief or your module practice, a table or figure might be better. To display these in a table would be relatively straightforward. Remember, for all of your tables, you need a title. You need to report the N in the sample. You need to indicate how you're reporting. Is it the mean standard deviation, median IQR, or median range? And usually you'll pick only one way to report. I've shown them all here so that you can see how to appropriately report them. And remember to always be consistent in your decimal places. If you wanted to use a figure, figure titles go below the figure. This is a relatively simple figure showing the mean age by group with a bar to represent the age, and then a 1 standard deviation error bar. Give the total N, use color sparingly, so only if it's purposeful. Make sure to be clear, and again, use consistent decimal places. This is the group means analysis and jump that takes you from your data summary through your fit Y by X to answer your questions using a p-value and then write a summary. We'll follow the same steps for the other bivariate analyses, even though we have different sets of categorical or continuous predictors and outcomes. Just remember to follow the steps as outlined and you'll always get your answer.